Hello, this is Professor Brown-Sederberg, and I'd like to demonstrate infinite loops. Infinite loops are loops that once entered cannot be exited. They're a fact of life in programming, whether you've been programming for 30 years or whether you're new to it. Typically, infinite loops occur because of a breakdown in logic or a failure to provide a means for the user to indicate they'd like to exit a loop. And I have examples of both of those. Now, infinite loops don't show up at compile time, they show up at runtime. Your program will compile just fine, but when you run it, that's when you'll experience the infinite loop. Now, I have here a for loop. I've declared an int I, given it a value of 0. My test is as long as I is less than 10, I'll go into and stay in this loop, and with each iteration I'll decrement I. Now this is an infinite loop, and it's an infinite loop because of a breakdown in logic. You'll see that I've established I with a value of 0. I'll go into and stay in this loop as long as I is less than 10, and I'll decrease I with each iteration. Well, I will begin with a value of 0. I'll test. Is I less than 10? Yes, it is. I'll go into my loop. My loop body is very simple. I'll just print the value of I to the screen. I'll print that value of I, come back up and decrement I. I now has a value of -1. I is still less than 10. I'll go into the body of the loop. I'll print the value of I to the screen, come back up to the top and decrement I. I now has a value of -2. I'll test I. It's still less than 10. I'll print the value of I, come back up to the top and decrement. You'll see that I will always be less than 10. This test will never be failed. As long as this test is passed, we'll stay in the loop. We'll continue to iterate. I am establishing I with a value of 0. I'm decreasing it with each iteration. It will never be greater than or equal to 10. It will always be less than 10. Now, let's compile this program, and it compiles just fine, and then we'll run it, and we'll see that as we run it, ever decreasing numbers are printed to the screen. Remember, we're decrementing. Now, an infinite loop will cause the program just to continue to run, and typically it will continue to run until it fills up RAM, and then your program will crash. Most IDEs do provide some way to stop the program, and here in Dr. Java, it's the reset button. I'll have this question asked, am I sure I want to reset the interactions pane? I'll answer yes, and the program is closed. Now, that's how I stop an infinite loop in Dr. Java. If I were in JGraphs with this same program, and here I have the same program, I compile and then run, we'll see that I have an infinite loop once again, and in JGraphs here the end button stops execution of the program. So let's go back to Dr. Java. We know how to stop an endless loop once started, but let's see what the breakdown in my logic is here. My breakdown was I cannot decrease I. If I continue to decrease I, I'll never have this test failed. And as long as this test is true, I'll execute the loop. My breakdown in logic was instead of decrementing, I should have been incrementing. And let's compile. And we'll run, and we see that my program runs as I had originally intended. It's a finite loop, printing to the screen 0 through 9. Now that's an endless loop in a for loop. Let's look at an example of an endless loop in a while loop. Now, a while loop is a loop that pre-tests. It tests before it goes into the loop. And I forced this while loop to execute at least once. Remember, because a while loop is a pretest, it doesn't always execute. It might never execute. That's what a while loop does. It tests up front. If the test is passed, the loop is executed. If it's not passed, the loop is not executed. Now, remember, a do while loop always executes at least once, but a while loop may execute 0 times. Well, I'm forcing this while loop to execute at least once because I'm making the test the value of again. And again here, we'll see, is a Boolean that I have declared here and given an initial value of true to it. And so this while loop, I'm forcing it to execute at least once. Now you'll look at what my while loop does. The body of my while loop is just to ask the user to enter in an int, gather that int, and store it into n. Now I'll compile this program, and then run it, and we'll see that I have presented to the screen the question, enter an int, I will. Enter an int again, I will. Enter an int again, I will. I can't get out of this loop. It just continues to ask me to enter in an int. What I've done here is failed to provide the user a way to exit the loop. And so what I should do here is to ask the user if they'd like to enter another one. And so I'll simply say I'd like them to enter true or false. I'll gather that with keyboard.nextBoolean, and we'll save that into the space again. So now when I compile, a clean compile again, the user is asked that first time to enter an int, and we'll enter that int. Let's make it 2. They're now asked, would you like to enter another? I'll answer true, and I'm asked, enter an int. I'll enter another. Would you like to enter another? I'll answer true. I enter another int, and now when it asks, would you like to enter another, I'm going to enter in false, and my program ends. So here I have provided to the user a way to enter information to cause the closure of the loop, the stopping of the loop. So here are 2 examples of infinite loops and 2 examples of how to correct an infinite loop. Infinite loops are just a fact of life in programming. We'll all run into them. You do know how to stop the running of a program in Dr. Java and in JGrasp. We know that those 2 IDEs present buttons to stop the program from executing. If you're on the command line, if you're on a PC, Control and C simultaneously will stop execution of the program. On a Mac, it's Command C. Thank you.